All right, so this question, what do we do? We've already discussed that if I plug in the number x equals 1, we get 0 over 0. We want to rationalize the numerator. Okay, good. Okay, and this is what we mean by that. What we mean by that is I'm going to multiply the top and bottom by 2 plus square root 9 minus 5x. Whoops, I think I put too many minuses in there. Over 2 plus square root minus 5x, right? You have to multiply kind of by a big fancy 1. Now let's make sure we get everything, the algebra here, correct. So, excuse me, up top we get difference of squares. So we get 4 minus 9 minus 5x. Make sure that 9 minus 5x is in parentheses, right? Or else you'll get the wrong answer. And then down below, which I should have written, let me write the denominator first. Down below, I get x squared minus 1 times 2 plus square root 9 minus 5x. And I am not multiplying out the numerator. Oh, sorry, the denominator. Right? The goal is to cancel common factors anyway. So you want to keep things factored. Don't start multiplying out the denominator. Like, don't start doing more than you have to. Keep things factored. Okay, so let's keep going. So hopefully everyone sees the algebra to do here. Bryn, what did you do next? Since I didn't get to hear from you earlier. What algebra did you do?
Spread out the top.
Okay, so I think your mic is breaking up a little bit, but I think I heard you. You said spread out the top, so essentially expand out the minus sign, and then we're also going to factor out the denominator. Okay, so up top, if I do everything, I get 5x minus 5, and down below, if I factor everything, I get x minus 1, x plus 1 times 2 plus square root. And up top, if I have 5x minus 5, I can obviously also just now factor that as 5 times x minus 1. So that's all the algebra, all the factoring. So make sure you have gotten to that step, right? Make sure you get all that factoring yourself also. All right, and now I'm able to say, aha, if this is the same thing as before, if x is approaching 1, x is not actually equal to 1.
Wait, it's a -5 on the top. You're factoring out a -5.
Is it? Let's see.
Right? Oh no, I'm sorry. So. It's because the negative distributes, and that makes the -5 a +5.
That's correct, right? Yeah. So up top, we actually get here. This thing right here is 4 minus 9, which is -5, and then plus 5x, right? So when I factor out the 5, I get just x minus 1.
Yes.
Okay, so we get this cancellation. Good. Now, once you are able to cancel that out, you know you're good, right? Because once that is the only factor that was causing division by 0, x minus 1. No other factor is causing division by 0. So once that factor is canceled out, you can just directly substitute. But let me just kind of write down what we have left. Okay, good. And now we use direct substitution property. So I get 1 plus 1 times 2 plus square root 4 in the denominator and 5 in the numerator. And what do we get here? 5 over 8. That's it.
How do you know which number to substitute? Is it just what the limit is?
It's just this, right? It's just x going to 1. Any questions about this? Okay, so now you can see why the already test, especially. Congrats, Manish. Why are we congratulating Manish? Why are we congratulating Manish? Why are you trolling the class, Jitesh? Why are you wasting our time?
I have a question.
Go ahead, Caitlin.
So when you're like just doing all the math, is the whole like process just trying to get something to to cancel so you can plug in the limit?
That's it. That's exactly it.
Okay.
Right. The whole point
Okay.
of this exercise is to simplify it using all your algebra skills to somehow cancel out that factor, because that's the thing that's causing division by 0. You want to keep your eye on that, and once it cancels out, you're good.
And in this first step, I always thought that like you would rationalize the like root when it's in the denominator. Is that wrong?
No, I mean, you can
Like,
rationalize anything you want. You can rationalize the numerator, you can rationalize the denominator, it doesn't matter. In this particular case, we choose to rationalize the numerator because that'll actually, I mean, you can see what happens. I mean, it lets us actually eventually cancel out the x minus 1.
okay.
Yeah, don't think that, oh, you can't have square roots in the denominator or anything like that. That's nonsense. Whatever a high school teacher told you that, just forget about them.
How do we know to rationalize? Like, I was so stuck on the first step, but once I multiply the top and bottom, I could do the rest of the equation.
So that's a good question. How do you know to rationalize? Honestly, it just comes down to experience, right? I mean, I think a lot of people may have thought, oh, let's rationalize that because you've probably seen so many algebra exercises at this point where you have this sort of difference of square roots where you just know, oh, I know if I use rationalization, it'll simplify. So it's just a matter of experience and getting used to it. Like you just know it'll work because you've seen it before. Okay.
Okay.
Yeah.
Thank you.
You're welcome. I mean, it's a good question. A lot of times, that's actually how a lot of math goes sometimes. You kind of learn a trick and now that's it. Now you've seen it, so now you know to use it.